Hey class, welcome to our third video on gears. So we've talked about where gears are used. We've talked about how gears can change torque, speed, and direction. We've talked about how we use what are called spur gears. And we've talked about how you find a gear ratio by comparing the number of teeth on the output gear and the number of teeth on the driver gear. Remember, the driver gear is the gear that's attached to the motor, and the output gear is the one attached to the wheel. In our last lesson, we had you figure out how to find a gear ratio. So if I gave you a slip of paper and said, all right, here's two gears. You have this gear here that's got 36 teeth. You have this gear here that has 12 teeth. How would you find the gear ratio? Well, we talked about how to find a gear ratio. You compare the number of teeth on the output to the number of teeth on the driver. In this instance here, our output gear has 12 teeth, and our driver gear has 36 teeth. Now, in a good math world, we want to make sure we reduce. If you remember, all these gears are divisible by 12. So 12 goes into 36 three times. 12 goes into 12 once. So our gear ratio is 1 to 3. The next question, is this going to give us speed or is this going to give us torque? So to figure out if this is going to give us speed or torque, we got to use some imagination. The other thing we can also remember is that motor and driver. All right, so this is the gear that's attached to our motor, and this is the gear that's attached to our wheel. So if we think, all right, this gear is attached to our motor, this gear is going to be spinning in a big way, and it's going to be spinning this little gear. And so if you can imagine that this big gear is going to spin once, and this little gear is going to spin 3 times, then that means that we're going to have speed. So remember, in our last video, we did a formal lesson and we took a look at this diagram here. We talked about how a gear ratio compares the output teeth to the driver teeth. Remember, the driver is the one that's attached to the motor. We talked about how to find a gear ratio. You compare the number of teeth on your output gear, in this case here, 36 teeth, and we compare the number of teeth on the driver gear, in this case, 12 teeth. So 36 to 12, and in this case, we have power. Now you might say, wait a minute, this same picture right here is in the last slide, and it was speed. Well, don't forget, it all depends where your motor gear is and where your wheel gear is. It all depends on where the driver and motor gears are placed. All right, so in this instance here, our motor was over here. And in the last instance on the other slide, the motor was on this gear. So just pay attention as to which gear is attached to the motor and which gear is attached to the wheel. And by comparing those gears or the number of rotations, you can figure out your gear ratio. So for new content today, we're going to be taking a look at what are called advanced gear systems. What happens when you have more than 2 gears? We're going to be able to figure out what is an idler gear and what is a compound gear ratio. Now, if you remember, in the previous lessons, we've only been focusing on the gear attached to the motor and the gear attached to the wheel. And we said ignore all the ones in the middle, because when you're finding a gear ratio, you're only concerned about the gear that's attached to the motor and the gear attached to the wheel. Well, what do we call those other gears that are there? That's what we're going to figure out today. So in some of your robots, you have what's called an idler gear. What is an idler gear? Well, an idler gear does not change the gear ratio at all, because remember, a gear ratio, you only are worried about the gear that's attached to the motor and the gear that's attached to the wheel. All an idler gear does is change the direction of rotation. That's all it does. So here's a diagram here where we have our driver gear, the one that's attached to the motor, and we have our output gear, the one that's attached to the wheel, and we have our idler gear. And if you look in the diagram, you can see how the direction of these gears are changed by using that idler gear. And you might have a situation where you need this. You might have a situation where you want the wheel here and you want the motor there and you want to fill in that gap of distance. So use an idler gear to do that. Or you want to make sure the gear and the motor attached to the wheel and attached to the motor are spinning in the right direction. So you might use an idler gear to do that. Those are just a few examples. But remember, an idler gear does not change the gear ratio. All it does is just change rotation. Here's an instance where you have one idler gear. All right, as we said, here's your driver gear, the one that's attached to the motor. Here's your output gear, one attached to the wheel. And in this instance, they've used a little gear to fill up that space. And so maybe you have some spacing issues with the size of your robot and you don't have any chains or pulleys or any other types of thing to fill in that gap. So you can use an idler gear to fill in that gap. And as you can see here, all it's doing is just changing the direction of rotation. Here's another instance where we have two idler gears. Again, we have our driver gear and we have our output gear. You can see how they're being changed in direction. Remember the three things that gears can change: torque, speed, and direction. Here we have gears being used to change direction. So you can see with having two idler gears, we are again changing direction. And again, even though we have four gears, the gear ratio is only comparing the driver gear to the output gear. Those are the only things that influence the torque and speed of the robot. All right, direction can be changed by using these idler gears. And so in summary, direction is changed by using idler gears. They're being used to fill up some space. And as I said in the last slide, in a motorcycle or in a bicycle, all right, it'd be impractical to use all these little tiny gears to fill up that distance. So in a bicycle and a motorcycle, they use a chain or a belt. In our VEX robot systems, we don't have chains, we don't have belts, so we use gears to fill up that distance that we have. And I want you to just know that when we use gears to fill up that distance, those little gears or big gears or whatever you use in between is only being used to change direction. That's the only thing that idler gears do. Now the last advanced gear system that I want us to take a look at are what are called compound gear ratios. All right, and what is a compound gear ratio? Well, these are very rarely seen in my class, but they are something that you could build. And so a compound gear ratio is when you have more than one gear on the same axle. And in that instance, each pair of gears has a gear ratio. Let's take a look at this picture here. So here we have this one axle here, and in this one axle, we have this 60-tooth gear. And then on this axle here, if you notice, we have a 12-tooth gear, and on that same axle, we also have a 60-tooth gear. And then on this axle here, we have just a 12-tooth gear. So what are we looking at here? Well, we can see from this little diagram that these two gears share an axle. So how do we find out the gear ratio? Well, remember, to find out a gear ratio, we compare output to driver. We have a little ratio written down here on the bottom. So we have the 12-tooth gear compared to the 60-tooth gear, because those two are a ratio. But we also have a 12-tooth gear and a 60-tooth gear over here. So that's a ratio. So when we take these two ratios and we multiply them, we get a 1 to 25 gear ratio. So what does that mean? It means that when this big gear turns once, it's turning this little gear 5 times. When this big gear turns once, it's turning this little gear 5 times. And because we have a compound gear ratio where we are sharing the same axle, we multiply these gear ratios together. And so when this big gear is turning once, it's turning this little gear, because of all the other gears, 25 times. Now you can imagine how fast that gear ratio would be and how fast your robot would go, but you can also imagine what's going to happen when you put that robot on the floor. It's probably not going to move. So if you're looking for a way to really increase the speed or torque of your robot, a compound gear ratio is definitely the way to go. And remember, you'll take an axle and put a gear on it. You'll take another axle, put a little gear on it. In that same axle, put a big gear, and then in a third axle, put a little gear. And what that will do is give you that compound gear ratio that we talked about, and you'll really be able to see the mechanical advantage of that robot in a big way. So again, what are some ways you can modify your robot to go faster? Let's say you wanted to build a robot dragster. How could you modify your robot to go faster? Well, hopefully from all these lessons, you know that you can use gears. All right, And by using gears and using a compound gear ratio, you can get your robot to go really fast. However, it's important to understand that there will be some challenges when you try to gear your robot for speed. Can you think about what some of those challenges might be? One of the big challenges that you might face is weight. All right, if your robot is too heavy, even though you have this really fast gear ratio, when you put your robot on the ground, it might be too heavy. The other issue that you might have is what's called friction. All right, that robot gets on the ground, but the friction from the floor and the tires slow your robot down so it can't go really fast. Unfortunately, with our Vex robots, we can't build a transmission. Most race cars and most dragsters have a transmission where they can go to first to second to third to fourth gear. All right, we can't do that with our Vex robots. There's no way to build that type of transmission. It's really, really complicated. So ultimately, you've got to find the best ratio that works for your robot, lighten it up as fast as possible or as light as possible. But there's a lot of different ways to solve that problem and trying to get your robot to go fast. And hopefully by learning some of the things we've talked about and seeing some of the things that we've talked about in the few lessons that we've talked about, you can kind of get a better idea on how to get your robot to go faster. So to review, in our gear lessons, we've talked about where gears are used. We've talked about how gears can change speed, torque, and direction. We've talked about how we use what are called spur gears. We talked about how you can find a gear ratio by comparing the output gear to the driver gear. We've talked about how an idler gear, all it does is change direction. And we've also talked about how you can use what are called compound gear ratios to give your robot even more speed and even more torque. Thanks for listening.